if you look at the process, then if you look at the processes, if you look at the processes, then there are certain operations on the processes. Though, so the operations include operations on the processes. On the processes, it includes three. One is called as one is called process creation, process termination. So creation means you're creating a new process. Termination means you're terminating a process, right? So what is exactly process creation means? Process creation means uh, whenever a user submits its particular job to a system, then it has to be created as a process. Okay, so means we are dealing with active entity or passive entity. So whenever it is into a running mode, it is a active entity. So the parent process creates a child process. It is a process creation. So means what? Say for example, if you look at this, so I have, say for example, one particular process. So this is process. This process is written. So this is not this is passive process, not an active. Passive. So passive process. So we can say this is a program in short, and this particular program is creating, say for example, creating say some n threads. So I can decide how many threads I need to prepare, say 4 threads, 3 threads, right? Whatever n number of threads that I'm going to prepare. So whenever this program is being submitted to a processor, processor as a process, then this becomes active process. This becomes an active process, right? So from passive it becomes active. So this particular usually transformation is nothing but creation of process. So this is actually creation of process. So this is there. So now this particular process, when it gets executed, it creates, say for example, n threads. So means what? You have got this one process, you have got this one process, you have got say this one, you have got this one. So now here n value is going to be 4. Okay. Now this is called as, so in this case this is called as parent process. This process created child processes here. Right? This has created a child processes. Right. It may be a case that this child process may create some more child processes also. Now, but these processes are being controlled. Their activities are being controlled, and again bring back all into the same parent methods. Okay, so it has certain segment of code, okay, to get executed. Okay, so so the parent process create the child processes, which in turn to create other processes also, and it forms a tree of processes the way it is being written, right? So created. So every process has a identified and managed by a process identifier, and that we have understood as a process ID. This process ID is going to be a part of PCB, that is process control block. Okay, now as far as resource sharing is concerned, parent and child, whatever the resources that are required for a parent, the child is being sharing all those resources. So parent and child share all the resources. Child share the subset of the parent resource. Parent and child share no resource. Either they share resource or they don't share resource, right? Likewise. So execution option will be parent and child executed concurrently. Parent waits till child uh, waits until the child gets terminated. So from here, say for example, it gets generating this. So either they can work concurrently, right? Parallelly they will work, or these four will work parallelly, right? And parent will collect the result and and wait till these four gets terminated, so that so that whatever the data that is required, or whatever the process that is being expected from this A, B and C and D are being completed. Okay, so once A, B, C are being completed, the parent will complete its particular job. Okay, so the as far as execution options are concerned, either this parent and child will execute concurrently, or parent will wait until the child terminates. So this gets terminated till that parent becomes active. Okay, so for example, at this particular point, at this particular point, say for example, at this particular point, the childs are being created. So this rest of the events are being executed afterwards. So these are the rest of the events which parent is going to execute. Okay, so this is called as process creation. Okay, now process termination is a method where you are terminating a particular process. You are taking that process out of the execution. Okay, you're taking the process out of the execution. So process executes the last in statement that is there, and ask operating system to delete the existence of that particular process using the system calls. Okay, so system calls are nothing but these are the daemons which are handling the processes. System calls are nothing but these are called as daemons that are created by or kernel level process. These are the kernel level processes. These are the kernel level processes that are being handled. Okay, so either a system call will be exit, right, or you can return the status of the child to a parent via wait. That can be done, or processes resources are being deallocated by the system. So means whenever you will say like this is run, to usually when it goes to complete, you can say here at this particular point of time you are deallocating getting all the resources which are allocated for a particular process, because till it is in the run, all devices are available. Okay, once it is shifting from its states from run to complete, it has to be deallocated. Okay, this particular can be done either by using exit system call, uh, or you can shift into a wait system call. So it means from here you can take it to wait, since it is an event. So here you can take from here, you can again get the last minute work into ready to run, and again deallocate the system. Okay, so it in this particular way. Okay, so whatever the termination that is going to be required as far as taking that particular process out of the process states, that can be done by using a process